bringing you the Algebra 2 Honors 5-1 homework solutions on nth roots and rational exponents. On this problem, I want the cube root of 8. So basically, what do I have to raise to the third power to get 8? And that's just going to be positive 2. For this problem, they want us to do 25 to the 3 halves. I'm going to rewrite this with radical form. So this is going to be the square root of 25 raised to the third power. Root is on the bottom, power is on the top there. Square root of 25 is 5, and cubing that gives me 125. On this problem, we're trying to do 8 to the negative 2/3 with no calculator. Since I have a negative exponent, I'm going to start by rewriting this with a positive exponent. This is just the reciprocal, so 1 over 8 to the positive 2/3. And now I'm going to rewrite this in radical form. This is going to be 1 over the cube root of 8 raised to the second power. Cube root of 8 is 2. And then 2 squared is going to give us a 4, so 1/4 final answer. For this problem, they want the fifth root of 32,768, and calculator is an option. So one way you could do this on your calculator is you could do 32,768 to the 1 over 5 power. That's certainly one way to do it. Or you could do nth root and put a little 5 up here, and then put your radicand in there. So 32,768, and that apparently comes out to exactly 8. Nice. Don't even have to round it off. For this problem, in order to solve for x, we first need to get the x cubed isolated. So I can start by dividing both sides by 5. And we've got, let's see, 1,080 divided by 5 is coming out to 216. And now I just need to take the cube root of both sides. So I happen to know, and you could plug this in the calculator, but I happen to know that the cube root of 216 is 6. 6 to the third is 216, so x equals 6. To solve this problem, we've already got the something to the fifth term isolated. So we can just take the fifth root of both sides. That gives me just x plus 10 on the left and fifth root of 70 on the right. Let me move that 10 over by subtracting it to get x truly alone. And now I'll just plug all this in my calculator. So I've got nth root of 70, so fifth root of 70, and then get out of there, and we're subtracting 10 from that. Let me just move this over a little bit. There we go. Minus 10. And that comes out to negative 7.66. For this problem, since the something to the fourth power is already isolated, I can just start by taking the fourth root of both sides. So that's going to be x minus 5 equals fourth root of 256. Since it's an even root, I need a plus or minus in there. And let me move the 5 over to the other side now. And the fourth root of 256 is 4, so this is 5 plus or minus 4. We can actually simplify this. 5 minus 4 is 1, and 5 plus 4 is 9. So those are our two answers for this. For this word problem here, I think that's pronounced a weir, is a dam that's built across a river to regulate flow of water. The flow rate, Q, in cubic feet per second, can be calculated using this formula down here, where this L is the length of the bottom of the spillway, and H is the depth in feet of the water of the spillway. So we have length and depth. We want to determine the flow rate of a weir with a spillway of 20 feet long and a water depth of 5. So this is pretty straightforward. They've given you a formula. You just have to plug in the length of the weir, or the spillway anyway, and also the depth. So we've just got 3.367 times 20 times a depth of 5, and that 5 is being raised to the 3 halves power. So this ultimately comes down to plugging it in the calculator. So here is our calculator to the rescue. We've got 3.367 times 20 times 5, and that 5 again being raised to the 3 halves. And in Desmos we trust, that comes out to 752.88 if you want to round it off. and that is going to be in cubic feet per second.